Okay, three forces A, B, and C act on an object such that the resultant force is 0. That's important. A acts at an angle of 150 degrees to B, and they both have the same magnitude of 20 newtons. Determine the magnitude of C and the angle it makes with B to the nearest degree. Now, they haven't told us what direction any of the forces are acting in, so we're going to need to make a call of where we're starting. Doesn't really matter where we start as long as we're consistent with how we go. So let's do our reference axis over here. There's my I, there's my J, and let's make the force A go in the positive J direction. I guess it just makes our life easier in terms of an orientation as such. Okay, and it tells me that A has a magnitude of 20 newtons. All right. Now it says it acts at an angle of 150 degrees to B. So B is acting 150 degrees away from A. So that's around about 150 degrees, and it's the same magnitude as A, so make it about the same size. So here's B. It's also 20 newtons, but that little bit of information is going to help me to resolve things. So if I put an axis in here, I know that that's a 90-degree angle, and so that must be a 60-degree angle. Okay. And we can sketch C in. We don't really know how big it is, and we don't know which direction it's actually acting in. But in order to balance force A and B, C must be somewhere over here, because it's told me that the resultant force is 0. So I'm going to make C over here, and we'll label this angle here, and we'll see how we go. Okay, let's define some variables. We've already been told what A, B, and C are, so let's let R be a resultant force, and it's going to be in newtons, and the forces are in equilibrium. So therefore, our resultant force is a 0 vector. Okay, and we know that our resultant force is the sum of all of our forces. So that means that our 0 force is the sum of all of our forces. And that then helps us to find C, because of course 0 and 0 is just 0. So C is just going to be negative A minus B. Okay, so we've kind of worked out the vector part of it. Now what we need to do is to resolve our vectors so that we can figure out what they are. And because of our orientation of A, we've chosen it very easily. It's in the positive J direction, so it's going to just be positive 20J. And B, I've labeled my angle there. It's a 50-degree angle. There's my right angled triangle. So there's my opposite. There's my hypotenuse. There's my adjacent. So my I component of B is going to be a positive I and a cos ratio, and my J component is going to be a negative J sine ratio. So I'm going to have positive 20 cos of 60 degrees I minus 20 sine of 60 degrees J. Okay, so I can then say, well, that means that C is, we've said it's negative A, take B, so we've got negative 20J, take 20 cos 60 I minus 20 sine 60 j. I can collect my I and my j components, and I have minus 20 cos 60 I minus plus minus 20 I'm messing up my signs here without thinking, plus 20 sine 60j. All right. I can, because those are cos of 60 and sine of 60, I know what those are, because I know my little triangle over here, 1, 2, root 3. Cos of 60 is a half, so that becomes negative 10. Or should we write the whole thing? Negative 20 times a half I plus negative 20 plus, and sine of 60 is root 3 on 2. That j should be outside. And that leaves me with negative 10I minus 20 plus 10 root 3j. All right, there's my vector C, but it wants us to find the magnitude of that vector. So our magnitude of C is our square root of x squared plus y squared, and that's going to be square root of negative 10 squared, negative 20 plus 10 root 3 squared, and we've got 10.35 newtons. Now we need to find our angle. Okay, so we know that here's the angle we're looking for. We've got our opposite, we've got our hypotenuse, we've got our adjacent. So tan will be opposite over adjacent. So tan of theta is opposite over adjacent, and that's going to be our j component over our I component. So negative, we want to ignore our signs. So yeah, it's still be negative 20 plus 10 root 3 over 10, and that means that we're going to have theta is inverse tan of that value, and that's going to be 15 degrees. However, that just gives us the angle to the negative x-axis. It doesn't give us the angle it makes with B. What we're actually looking for here is this is the angle that C makes with B. So if I know that that one's 60 degrees, this one's 15, I can use angles on a straight line to find the angle that it makes with B. Therefore, the angle that C makes with B is going to be 180 degrees minus 15 degrees minus 60 degrees. And we can write, because of angles on a straight line, so that's equal to 105 degrees. So therefore, the magnitude of C is approximately 10.4 newtons, and the angle between B and C is 105 degrees.